Alright, hello everyone and welcome back to my LEGO Mindstorms walkthroughs. Today we will be going through the sensor tab. Yesterday we went through flow control. We might use some of these today. It all depends on how we want to show some examples. So for the first one, we have the brick buttons block. So I made a quick little program to demonstrate this here. It's basically just a switch inside of a loop that's looking for something. So I've set the switch to logic type, and the loop is going on for forever just because it's just a demo. It's not really going to be doing too much, especially because the only action it does is say hello. So it's not a very useful program, but it's a pretty good demo. So here, basically, what I'm doing with the brick is I'm comparing. Um, there's different modes in the brick button. Here you can measure. I guess I can talk about that here. So here you can measure the brick buttons, and this will basically just give the button ID to which button is being pressed, and it will output it as a number. Here you can see which button is the button ID. So 0 is nothing, 1 is the left one, 2 is the center, 3 is the right, 4 is the top, and then 5 is the bottom. You will get those numbers if you do this, and then you can just tie that into your logic and whatever you want there. And then next you have the compare type. Here you can set what you want the robot to compare. Here it will you can choose which of the buttons you want it to look for. So say I want it to go the left, right, and the left, center, and the right ones. So if any of these buttons are pressed, this value will be true. And here you can choose what state. You can have it released, pressed, or bumped, just like the touch sensor. And this one will give you a true or false. Notice how this wire is green, not yellow like this one is. So this will give you a logical true or false statement, while the yellow one will give you a numeric statement. Here it will just give you the button IDs of what's being pressed, and this will give you the true or false for this argument. Yep, that's basically all that this one is. So to demonstrate this, I have made this program. So here, if you press play, this is just a switch inside of a loop. And the switch is on logic mode, so it's checking if this is true or false. So if the middle button is pressed, which is state 1, if it's pressed, then this will be true, and then this true will go straight to the switch, and it will go into the true statement here, or the false statement, which it does nothing. So what happens is if I press the center button, the robot will say hello to me. And this will go on forever, unless I set some sort of AND condition, which we talked about yesterday. Alright, that's basically it for the brick buttons. Next we have the color sensor. Here you can use this guy for line following or just detection in general. So in the first one, you'll have you can measure color, reflected light intensity, and ambient light intensity. Here it will output a number here. Whatever color it sees, it will tell you that through the string. So you can do logic with it. So you can be like, if it sees green, then do this, or something like that. Next, you have reflected light intensity. So the color sensor actually has a little light on it. That's the little like the white area right there, and this is the actual sensor. So it has a little bit of light right under it, and it can illuminate whatever is in front of it. Here, it will actually measure the reflected light intensity from that light. So if it's a very dark surface, it's gonna absorb a lot of the light that's reflected onto it. But if it's a white or very bright surface, then it will reflect a lot, and this value will go up. This is basically just a numeric value where the lower the number is, the darker or the lower the reflected light intensity is, and then the higher the reflected light intensity is. Next, you have ambient light intensity. So here it does not turn on that illumination or that light there, and it just looks at the surroundings, and it will measure how much of the surrounding light is being reflected. Basically the same thing, just without the light on. So here you can compare. This is where you can actually get some logic in. So you can choose what color it's looking for. So say I wanted to look for red and blue. I can select both of those, and if either of those are seen by the color sensor, then this will be true, and then this one will give you the actual color that it's seeing. Same thing for the reflected light intensity. Here is checking to see if the measured value is less than 50, and if it is, then this will be a true, and if it's not, then this will be false, and this will give you the actual number itself. Same thing for ambient light intensity. And calibration here, it's pretty important because where you're testing your stuff in your test bench and everything, your reflected light will be a lot different than it will at competition if you're an FLL, for example. So in FLL, you have the big floodlights, and there's all the different light sources that are going on. While in your home, you might only have one white light. So here you can actually calibrate it, so you can put your robot over a very bright spot on the mat, and you can calibrate the maximum, and whatever it reads, it will set that to the 100 value. And then you can also calibrate the minimum, so put it on a dark place, and it will calibrate it to a minimum. This will work. This is very important, so that you guys get the exact values and there's no problems there. All right, that's the color sensor there, and then now we have the gyro sensor. Here, this is also very important for precise turning or any sort of movements that you want extreme precision with. It's very important. So here we're in the measure. You can measure the angle and the rate of movement, or you could measure the angle and rate. So here the angle is just the raw angle that it starts off. Whatever you start your robot at, it will be the 0 value, and then as you move it left to right, it will change this angle value. While this rate value will actually change depending on how fast it's turning. So if it's turning very quickly, then this rate will go up, and if it's turning very slowly or not at all, it will go to 0. Even if it's been turned from its original position, but now it's stationary, this rate will be 0. Next, you have compare. Here it's the same thing as the color sensor. If the red value is less than some number, then this will be true or false, and this will be the actual rate that you see. Here you can change this comparison type, of course. It can be greater than, equal to, all of the different comparison types, and you can change this number to whatever threshold value you need. Same thing for rate here. Instead of the value, it's the rate. And then you can reset the gyro. So after some movement, you can reset it, and then whatever heading that it's facing in now, as soon as it's reset, will turn into the new 0. So this is pretty important, as you won't have to worry about the bringing angles over. So if you move 30 to the right and then you want to move 30 to the right again, you don't have to worry about, oh, I'm going to have to hit 60 instead. You can just hit reset, and then next will be 30. Okay. And then next you have the infrared sensor. This is unfortunately illegal in FLL so far right now as I'm filming this, but it is a pretty cool sensor that you can use. It measures, it's just like the ultrasonic sensor, however it measures distance, and it talks to a beacon instead of just the environment. So here, when you're in the measure and then beacon mode, you can choose which channel your beacon is on, and there are 4 channels here, and then this will give you a heading number. So this is actually where's the beacon in relation to the sensor. So if it's a little bit to the right of the sensor, it will give you a positive number, and if it's a little bit to the left of the sensor, it will give you a negative number. Here you can drag and drop this into your logic, and there you go. This one is proximity, so how close is it to the beacon itself. This will also just give you a number, and this one will see if it's actually detected or not. So if the infrared sensor doesn't even detect the beacon, this will give out a false statement, but if it does, then it will give out a positive statement. Next, you have proximity. Same thing here. It will just measure the distance from the infrared sensor to the beacon. And then remote is you can actually program the remote, and then you can use this button ID to do things in your program. This is exactly why the infrared sensor is not allowed in FLL, because you could control it while the robot's moving, like a teleup, which is just not allowed. It's supposed to be fully autonomous. Next, you have compare. It's the exact same thing as before. We're comparing proximity right now. So if it's less than 50 centimeters, then it will give out a true or false, and this will give you the actual number. Same thing for the beacon heading and the beacon proximity. The remote, also the same thing here, just true or false, and then which one is actually being pressed. And make sure you have the right port for all of these sensors, or else they will not work. You should get a little yellow diamond. That's a warning symbol right up there, and you can that should help you figure it out. All right, next we have the motor rotation. Here, this will actually measure the amount of movement a motor has. So you can measure it in degrees, rotations, or current power, which is the actual amount of power that's being supplied to the motor, or if the motor is supplying power to the battery. Make sure you have the right port that you want it to communicate to. It doesn't matter if it's a large motor or a medium motor. This works for both. So you can this will give you out a numeric statement, and you can use this number to for logic, and then you can compare. Same thing here. You can have your comparison type and then your threshold value, if it's true or false, and then the actual red value. That's the same for all of these, and I don't think I have to go through that. Yep, and then you have your reset value. So this will actually just reset the rotor to 0 wherever it is in the program. So if it's moved, say, 100 rotations, and you want to do some math starting there, you can just reset the rotations, and everything will go to 0, and then you can do 10 rotations from there, for example. Next, you have the temperature sensor. Here, it's the same thing. We don't really use this one too much because FLL doesn't really have a temperature aspect yet. Maybe they'll add it in the future. So the measure will basically just give you a numeric number. For Celsius and Fahrenheit, it will just give you out the red temperature. And then compare, same thing here. It will just compare it to whatever threshold value you have. It will give you a true or false, and then the actual red number. Same thing for Fahrenheit. Alright, then we have the time. This is the timer block here. The first thing you can choose is the timer ID. So this is basically the robot can store up to 8 timers at the same time. And you can time different parts of your program based on what timer ID it is. And then this will just give you the elapsed time for that timer ID. So next you can compare this. Choose whichever timer ID you want to use, and then compare it to your threshold value. You'll get your true or false and your elapsed time. Next, you have the reset button. This is where it gets important. So you can reset a certain timer ID when you say start a certain part of your program. So say I want to start reset timer ID 2 and then read timer ID 2 later. I can do that through here, and then all the other timer IDs will not be touched, which is very important. Next, you have the touch sensor. This is also a very important one. Here, you can measure the state. So it will actually give you a true or false statement here, whether or not it's pressed or not. If it's pressed, it will give you a true. If it's not, then it'll give you a false. Next, you have compare. Here you can see all of the different states. You can have released, pressed, and bumped. Bumped is basically when it's pressed and released very quickly. I'm not sure how you would use that, but it's there if you need it. Next, you have the true or false. So if the touch sensor measures a press, then it's true to this statement here. It'll give you a true or false, and then it will also give you the numeric value 1, 2, or 3. There we go. That should be it right there. Next, we have the ultrasonic sensor. This guy basically just measures the distance between the sensor to a certain object on your field. Here you can measure the distance in centimeters or inches. You can also measure presence. So if or if not, it actually measures something. If it sees anything, this will give you a true or false here. You can also go into advanced and go into advanced centimeters. Here you can change the measuring mode. If you wanted to just ping it once, it will just send out a quick burst and then listen for it to bounce back one time. Or you can have it at continuous, and it will constantly check what the distance is to the environment. You can also do this in inches. And next we can go into compare. Same thing here as earlier. You can compare it to some threshold value, and you'll get a true or false and the actual value that it's reading. You can also go into presence. Here you'll also get a true or false. Next, you have the sound sensor. Here, this is the NXT sound sensor, but you don't need an NXT to use it. You can actually, they're backwards compatible, so EV3 can also use the NXT sound sensor. Here you can measure the audio level here in decibels, and you can connect this to do some math if you want to. You can also compare it to to an argument. So if it's greater than threshold value, true or false, and then the red value. And then you can also calibrate this. So if you're in a very loud environment, you can calibrate whatever the sound sensor reads as the 100 And you can also calibrate it to be the minimum if you want that also, if you go from a loud to a quiet place. All right, I think that should be it for sensors. Tomorrow we should be looking at the data operations tab. This is where it actually where we get all of the math, all of the very analytical stuff. Very exciting. And yeah, thank you for watching. If you have any questions, make sure to leave them in the comments below. And yeah, I'll see you next time.